So it's now a couple of weeks later. I've got some more parts. Don't have all the parts I want, but I've got most of them. So we can carry on now and do some more replacements. So I've got some replacement capacitors to replace the film cap over here and the paper caps on the back. I've also got some replacement resistors, because although we replaced these resistors over here before, so although we replaced those already, I'm not happy with them because they're getting too hot. So I'm going to replace them again with some higher wattage ones and just try and dissipate a bit more heat to keep them cooler. That's the hope anyway. I've got a proper 22k this time instead of bodging one with 20 and a 2k, and I've also got some new 10ks as well. So these are 3 watt resistors. The original ones I put in there are 1 watt resistors or 2 watt resistors, something like that. I think they might be 1 watts, and they're just not really handling the heat so much, so I'm going to replace those. So we get those done at least. I'm still waiting for a new eye tube. That's still got to come. I've ordered one. Hopefully it's okay. This particular tube is a little bit weak, and that's a 6E5. I was actually watching a Mr. Carlson video yesterday. He's talking about 6E5 and 6E6, and 6E5 is the more sensitive one. So first thing I'm going to do is replace these 2 paper caps, get those out of the way, because those are the most dangerous parts about this whole unit, is that these could fail and destroy the valve completely or whatever, or some other valve. This one I'm going to replace anyway. I'm not too worried about that, but I don't want to blow one of these other ones up because I don't have spares for them. I need to get these out. These both go to ground one end, so that's easy. You've got a forward designation as well, which should always go to the lowest side. These replacement caps I'm using here, these are metallized PET. That's what I'm going to replace them with. I don't think they've got a polarity. There's no markings on them anyway, so probably not. I'm not that familiar with this sort of stuff. I don't normally use these caps, so this is a new territory for me as well. I have to remember that the 0.1 goes to this end and the 0.5 goes to that one in between. So 0.1, 0.5. I can get that back to front. So 0.1 is the top one. Come on, come out. That's wrapped, isn't it? Of course it's wrapped. That's annoying. Let's try the other one. No, I'm going to cut those. These ones I can just pull out. I did that last time. Okay, so these are 0.5 plus or minus 20%, and also you can't get 0.5s that easily anymore. So these are 0.47s. It's fine. And it's got this sleeve on here, might as well use that. So I can probably even shorten these up and make them a little bit nicer, but I need to keep enough slack in here so you can move this around to get the eye tube in and out. So I probably will keep it quite slack actually. So what I might do is actually attach the other end, poke that through, so there you go, just like that. Now I'm not sure if I actually do need to have them cut up to the chassis or not to try and improve the shielding. That may be an idea actually. Maybe it doesn't matter, I don't know. I might just leave them hanging out like this. I'll still do that. And let's put some fresh solder on this. So that's that one. So the original cap there, these are, as I started saying anyway, so 0.5 plus or minus 20%, so you go down to 0.4 to 0.6. And 200 volt rated. The other cap is also 200 volt rated. And again 20% tolerance. So the 0.47 is well within the tolerance of that 0.5 with the plus or minus 20%. These are 250 volt rated. And the other ones here are 630 volt rated. It's actually quite a pleasant surprise to have the price on these be a lot cheaper than what I'm used to buying when I'm buying electrolytics. Yeah, that's quite nice. Anyway, get the sleeve off that one. I'll do the same thing, I'll poke it through here and then I'll connect it up there. No, can't find a hole. That's always a problem. There we go, here's a hole. Right. Let's get this other end attached. It's funny that the 0.1's bigger than the 0.5, obviously because of the voltage difference. That's it. Alright, that's those two done. So So now I'm going to replace the 0.05 microfarad here, which is a plus or minus 20%, and it's also 200 volt rated. So here I've got a 0.047, also marked 473, and that's 630 volt rated, this one. So yeah, that's, you know, a bit of an upgrade. Obviously I've still got the electrolytics in here, but I checked them out previously and earlier in the video, and they seemed fine. They're only, what, 40 microfarad, but the 350 volt rated. Don't know if I've got anything to even replace them with, actually. If I wanted to replace them, what's this? 100 volt, yes, I've got nothing suitable. So I wouldn't bother with that yet. I mean, I've got no reason to replace them. If I needed to, I would get the parts in and do it, but right now they're testing fine. And for me that's really unusual. Normally if it's got electrolytic caps in it and it's a device I'm going to keep, like this will be, then I will replace them regardless. Yeah, it's probably not worth it because they're testing fine anyway. There's no signs of them being a problem. They might last another 10 years yet. So in this case I'm going to leave them alone. If I had any suspicion about them, then I would be changing them regardless, but like I normally would. Anyway, we get to this. Yeah, it's wrapped. Let's cut it off. It's not easy to get to that one. What I was actually quite surprised by is that they didn't actually have any kind of insulation on those legs. I'm also wondering if I should just stick it across the back like that. Or is there a reason it's down here? Maybe it's for noise? It's possible. I might stick some insulation on his legs on this thing, just to make sure it's not going to touch anything. There you go, bit of insulation there, bit of heat shrink, nothing too special. Let's put some fresh solder on these, give it a chance to get a decent solder joint. This one's a bit harder to get to. Come on. There we go. Right. So that's the capacitors done. Now I need to come back and do these resistors again. I should really push the record button. This usually helps to make a video when you're recording at the same time. Get that side off. Already started desoldering these, but it's not easy to get these apart. There we go, that's that one. That's a 22K. We've got the 10K off. Now because this is basically a resistor ladder, there's actually a chance that a lot of these resistors will be getting very hot whilst they're being activated. So it depends on the switch position as to which ones are being used. So it might be that if I turn the voltage right up, that a lot more of these will be getting hot. So I don't know. Well, it could just be that it happens to be the ones on the end because that's what are the ones that are exposed to most of it, but for their biggest voltage drop. So anyway, we're going to put new resistors on here and then we'll be able to power it up again. So because I'm worried about accuracy of these and I'm fussy like this, I'm going to replace a piece of gear. I like to make sure it's as accurate as I can get. So the original parts are only 5% rated anyway, but accuracy to me matters. If you're going to put something in there, do it right. So these are 5% rated, so the original parts are 10% rated. So I'm just looking through here to see if I can find one which has got exactly 10K. So I've got some 9.99s, which are closest we've got so far, which are pretty good. And as you can see, because these are 5% tolerant, there is a tolerance there. So I'm just trying to find one which has got the best accuracy, it's given the best result in the end when it's installed in the unit. So we've got three which are 9.99, I'll just go with one of them. That's fine. We'll use that one. And I'll do the same thing with a 22K as well. So we can find one which is as accurate as possible. 20.05 is the second one. It's closest so far. Come on, get on there. You can see the tolerance is changing all over the place. 20.29, 98. Or 21.99, that was really close, that one there. But you see how much they're changing by. So when you're doing something which is a bit more precision, or you want better accuracy, check your resistors. Don't just assume that the value which is marked is what you're going to get. If you want accuracy, select the one you want. There we go. I'm going to twist together the end of these resistors because they do have a common junction point, so I'm going to do this because it will mean soldering should be, well, maybe a bit easier, maybe harder, but we'll do that. Give it a twist together, we'll solder these up, then we can try putting them in. Now I shouldn't need to really refresh the solder in the actual unit with the switches, although it is looking a bit dull. I might actually try and clean some of that off actually. Normally I wouldn't worry about it, I'll just put some fresh stuff on, but it's looking a bit dull, so I will actually strip off some of the old stuff. It's obviously not doing quite so well. So I already put more solder on last time I did these replacements, but it's getting excessive and it was looking a bit dull. I wasn't happy with that. Let's put some fresh stuff on here. So there's already still a bit there still. Okay. Should really have my extractor fan going, but it's not going to be too effective up here anyway. Now I must get these the correct way around, otherwise it won't work. Red, red, orange, that's the 22. Brown, black, orange, that's the 10. So what I might do is solder that piece on first. The hardest bit is getting the soldering iron while soldering, holding parts and recording video. Once attached I'll do the other ones and I'll come back and re-solder it again afterwards, so I'll get a nice solder joint. That's one on. Well, let's try and get this one soldered. Just there, I've got it kind of bent into place, so hopefully it will attach when I do this. Seems to have done it. So the other thing I'm trying to do now is actually separate the resistors so they're not actually touching each other, just to give them a better thermal area, because if they're touching then it's going to be less heat emanated from them. Obviously heating is the issue I've got here, so I want to get as much heat out of them as I can, so I've got them separated a little bit to try and help that. Right, let's try and solder this last one on. So I've got those parts replaced. Now what I want to do is power this thing up and test it obviously and make sure it's actually going to work. Then I also need to check the thermals to see if anything's getting hot. Turn the power on there. Right, let's power it up. Spin this around, check for anything going horribly wrong straight away. So far okay. Same deal here, so far okay. So far the resistor's looking alright. Let's try increasing the voltage setting. Nothing really showing up for the new ones at least. These other ones here looking a bit warm around the outside, but check a capacitor with this. So I've got a capacitor already hooked up. One of the ones which I took out of the unit. I might have to turn my lighting down because you can't really see it. So it's going to get grainy. So it's coming on discharge. Let's put it on leakage. I want to do leakage. Got it set at 6 volts. It's a 200 volt cap. Not showing anything. Maybe I should be on the other one. Paper mica. Maybe I should be on that one. It's a film cap after all. Maybe I should do that one. I can see it flicking. But that's about it. Nothing there sharp as being bad. That one actually passed. Let's check the paper caps. What's that on there? 0.1. No, that's not showing any leakage either. I'm surprised actually. It's 0.5. $200 volts. No, still looks alright too. That's actually really surprising. So I was checking the thermals again on here. Now it's had a bit of a chance to warm up a little bit. So I've got one resistor up here which is currently 84.7 degrees, which is a 330k, sorry, a 33k resistor, which is going to cross that supply there. The other ones in there are actually looking a bit colder than that one. That's like the hottest one, I think. A bit hard to tell. I've still got my lights off so you can see the screen a bit better, otherwise, you know, it might be a bit harder to see. And there's the resistors on the back of that switch. I'll try and get the lighting away from that if I can. There you go, 66 degrees. That's like the hottest one on that switch so far. So that's not too bad. It was about 80, I think, 80 to 100 on the very first resistor, that 22, which I replaced. So that's handling a lot better. There you go, 70, that's on the 22. So that's doing a lot better now. Happy with that. And the others are looking pretty much alright. Yeah, I think we're fine. We're looking good there. So now I'm going to test voltages whilst it's doing a leakage test to see what it's actually handling the load like. So 150 volts right now, we're getting 151. It's 200 volt caps, so go to 200 first. There you go. It's basically there. So 100 volts, 299. 50 is doing 48. 25 is doing 25.8. 15 is doing 14.4. And these are all close enough to not worry about really. 10 volts is doing 9.5. 6 is doing 5.5. And 3 is doing 2.9. That's fine. Okay, so let's do this without the capacitor connected to it. So 25 volts. Yep, that's what we're getting. Now I can go above 200 volts now because there's no capacitor attached. So 250 is doing 248. 300 is doing 299. 350 is doing 347. 400 is doing 398. 399 even. 450 is that? Doing 455. 500, 504, 600 is doing 610. Cool. So without doing a calibration, I'm just going to do a test, and we'll do a capacitance test. I don't know if this is relevant for the capacitance test or not, but it's 200 volt caps. I'm doing it at 50%, and we'll just bring this over here to the bridge mode, and we'll see if this 0.1 microfarad cap does come back as 0.1. It hopefully will. Let's see. So this eye should open up once we get there. We've got this power factor thing here. I've got to figure out how to use that yet, but I think it's over here somewhere. Yeah, it is. Look, there we go. It's very touchy right there, and it's reading just below 0.1. So that actually worked. I don't know if voltage is relevant to that. Let's actually do a measurement, see if there's any voltage changing on that at the same time. No, I'm only getting 2.7 volts across there, so it does that in the low voltage mode. So what this is set to is irrelevant. Let's check the other one. Considering I haven't calibrated this yet, it's pretty close. It will need recalibrating. I'm going to do that again once I've changed the valve up here, because that might affect the readings. Right, let's do this bridge mode again. So this is a 0.5. There we go. And it is just over 0.5. That's working. The other one here was a 0.05, so that's going to be right at the bottom of the scale here. Not much good for us. This needs a new magic eye tube because it's really faded and dim. So I'm hoping that I can put this one in. If this works alright, I might actually buy another one. I don't have any spares. I like to have spares of everything. Always have spares of everything. Get them while you can. So the replacement valve just arrived for this thing. I've just put it in. And I showed it in mailbag already. I'm going to repeat it. Here's the old valve. It's the 6E5. The new valve is installed. Let's power it up. And we'll show you how bright it is. Remember before, hopefully, I have to cover it up, basically have it show up on camera at all. So let's give it a minute to warm up and then it will show up. There we go. You can see it on camera just fine. I covered up. It's really bright. That's much better. That looks really good in person now. Before, I could barely even see this one. Even like myself, I could barely see it. So the new tube's in there and it's looking great. Hey. Excellent. Really nice. Big improvement. So I've now ordered a full set of replacement valves for this thing, so I'm going to order another one of these. Now I notice this supplier is good. I've purchased another one from him. That wasn't cheap, it was like $50 with postage. Wasn't cheap, but you know, it is what it is. I've ordered the other pair of valves as well, so I'm going to have a full set of valves for this thing. So if I ever need to do any repair work on this thing in the future, I've got a full set of valves. So, excellent. This will be going for another 50 years, I reckon. Alright, so let's go and do the calibration on this thing. I've already started, but I've just got myself sort of set up and doing basic checks. So, the first thing we've got to do is electrolytic mode. 50 volts on discharge when doing connections, obviously. I've got these leads hooked up, so I've actually got this bridged across here. So this is going through my little resistance box here. Instead of using a variable pot, which is what it states, I'm going to use this to generate the resistance instead. I've got it linked across between the two cables, and it goes straight into the multimeter. So this is measuring milliamps. So what I'm supposed to do in the electrolytic range at 50 volts, I'm supposed to set this up for 2 milliamps on the display across these terminals, using this resistance box to get that. And then you adjust the top adjustment to get the magic eye to just shut. Okay, you got that? So I've already done some adjustment, which is easier if I don't have a dodgy connection down here. There we go. I think I need to look at this and find out what's going on here, because I'm getting this problem. If it's a binding post, maybe? Don't know. Got something going on there. Anyway, there we go. So let's just get this set to 2 milliamps again. I was playing with it before. So it should basically get down to 2 milliamps, and this should be basically shut at 2 milliamps. At least that's the theory. There's a lot of dirt in there actually, coming out on these terminals. That needs clean. I've got some of the lights off too, so you can see this a bit better. But that's why it's a bit dark. But that's the dirt just out of that one terminal. Definitely good clean up. I'll come back. Okay, I've cleaned up this terminal a bit more. It's a lot better, but it's still not perfect. I'll have to do some work on these. If I can't get them cleaned properly, I have to replace them. We're getting 2 milliamps, and the eye is almost shut. Okay, so I'll adjust it now. It's close enough. Let's give us a tweak. Just shut. There we go, that's the first one done. Now the manual for the next stage is actually a bit vague. It sort of says reduce the voltage and adjust the pot, which is trimming on here, to get 15 microamps in the milliliter range. So it's not particularly clear about exactly which one it wants. It's sort of, I wish it'd be nice actually said which one it wants for the voltages. It just says reduce it. It's not particularly helpful. So I'm just trying to sort of get this to trim to be about right. Yeah, I'll come back. So something I have noticed is by changing the line voltage, because I'm wondering why it's sort of drifting up and down a little bit, but the line voltage changing over here is changing the current over here. So if I drop this down slightly, see the current's changed. So I'm going to have to watch out for that. I don't know about how accurate this is really going to be then. If it's so sensitive to line voltage changes, I'm only changing it by a couple of volts, and it's shifting by a fair bit over here, so that's interesting. So have to watch out for that, I guess. We'll set this one up now. So this is the bottom adjustment. So just shut there. Okay, bottom adjustment. That is very different to what it was originally. Anyway, maybe to the different tube. Let's do the next one. So I'm just playing with this a little bit, and I'll change the voltage down to 10 volts, and I'll change the resistances on here. Get back to 15 milliamps again. The eye tube just closed, so obviously that 15 milliamps is the setting for the eye tube. Basically, that is where it will shut. So it doesn't seem to really matter too much on voltage. It depends purely on current. Okay. And the next setting is for 2 microamps, which is just drifted off very slightly. So let's do the middle one. Again, there's a screwdriver slot in here somewhere. It's got some gunk in here, see, which hasn't helped. Someone's gunked it up with some silicone. Now I've got to try and find where the slot is, because I can't see. With that said, the tube's closing up by itself at 2 microamps. That's interesting. No, it's opening again, just a little bit. Well, that's curious. Could be my line voltage changing slightly. Let's drop it down just a fraction. You see it's changed the eye quite a bit. Change the line voltage. That particular one's very sensitive there, it seems. Yeah, it's a bit drifty. But it's actually really close to right though. So we got a 1.9 odd microamps, now it's open. 2 microamps, it's just about shut. 2.1 microamps, it will be, yeah, basically, and it's overlapping slightly. So yeah, that's really close. I think it's probably right where it is.